Welcome to DP Tutorials by Donny Jarwa. In this teaching module, we will learn on electric potential due to a point charge. The electric potential due to a point charge is very important, especially the derivation of its equation from examination point of view. So over here, let us take, suppose at point O, let us place a point charge plus Q at point O. So let me assume that this point is point O, and at point O we will place this charge, which is plus Q. Okay, plus Q. This charge is what is known as the source charge. Okay, this plus Q is also known as the source charge. This is also known as the source charge. We know that when we have any charge, there will be electric field associated with that charge. Let E be the electric field produced by the source charge, which is represented by certain vectors, and all these vectors are pointing radially outwards. Suppose the electric field due to this source charge, plus Q at point O, be experience up to, suppose, point A. Let this be point A. Okay? Let that be point A. Then over here, let this distance of the point A from the source charge at Q be x. Then that means from O up to A, let that distance be x. And then suppose at this particular point, let us place a test charge Q0. Okay? This Q0 is our test charge. Okay? So this Q0 is our test charge. And let this Q0 be at a distance which is located at infinity. Say, if you want to move this charge from infinity, this Q0 from infinity up to A, we have to do a certain work. Okay? It is obvious that we have to do a certain work. As we want to bring this charge Q0, very close to the source charge. This is your charge Q0. If you want to bring this charge Q0 at point A, you have to do a certain work. Okay, Say, if you want to bring that up to that point, you have to do a certain work. Even if you want to bring that charge up to a certain point, say, like for instance over here, suppose let that point be point B, again you have to do a certain work. That means this will be work done in moving the charge from infinity up to point A, and this will be work done in moving the charge from infinity up to point B. Then let us assume that this distance between these 2 points A and B are very, very close to each other, and let that distance be dx. So this dx is the distance between point A and point B. And over here, I will assume another point C, which is very, very close to the point O, or the point where the source charge is located. Let that point C, let the distance of that point C, from the test charge be R. So we'll write over here R. Then we know that since due to the presence of the source charge, there will be electric field. So the electric field at the point A, which means at this point A, is given by what? Is given by the expression E equal 1 divided by 4 pi, 1 divided by 4 pi epsilon 1 Q divided by 1, Q divided by distance square. So what is the distance from O up to A? The distance from O up to A is 1, less than x square. So this is the relationship. This is the relationship, or the electric field at the point A due to the source charge. Okay. Then next, suppose we want to find what is the strength of the electric field. The strength of the electric field E up to point A is given by this expression. Then say if you want to bring this charge from infinity up to point A, from infinity up to point A, and again from infinity again up to point B. And when the charge is located at B, that means you want to move again that charge very close to point O, that means say up to point B. That means you have to do what? You have to do a certain amount of work done. If dx is that elementary displacement, if dx is that this dx is our one, that dx is your displacement. Okay? Your dx over there is that small displacement or distance. I have written over here that dx, this dx is its distance, or we can define it as the displacement. Then when you do certain work between these 2 points A and B, then what will happen? You have to do some work. Okay? In order to move the charge from A up to B, that means you have to do what? A small amount of work done. That means that amount of work in moving the test charge between these 2 points, okay, between these 2 points A and B is given by what? Is given by some formula. You have to know what is the formula. Then we know that work done is what? Force. Okay, work done is force into displacement. Force into your displacement. Or in this case, if dw is that small work, then it is F. If F is the force, if F is the force in moving from E up to B, then F dx. Okay? F dx. Dx is our displacement. Dx is our displacement. So this is the concept. W, dw is the work, F is your force, and this dx, which is written by S, this is your displacement. Okay? That is your displacement. So in this case, we also know, okay, some relationship. Okay? We know some relationship between force and electric field. There is an expression, okay, between force and electric field. We know that the force, okay, the force is Q times E. Okay? Force in moving that test charge, so that force in moving that test charge is minus Q naught into E. Why we take this negative sign? The negative sign here is very, very important. Okay? Force, that means when you bring this charge from infinity up to E, you are doing some work. And again, when you move from E up to point B, you have to do some force. Okay? Some force. So over here, when you look from that figure, okay, since this is the positive charge, the electric field will be represented on this direction. That is the direction of the electric field due to the source charge. But when you move this charge, that means you're moving this charge, that means this force, when you move from E up to B, is in the opposite direction. That electrostatic force is in the opposite direction. Let me write it properly. That electrostatic force is in the opposite direction, which means that is the reason why we have put over there F and E to be oppositely directed. So over here F is equal to Q minus Q naught E. What is the reason of this negative sign? The reason of that negative sign is because the electrostatic force in doing the work on that test charge against the electric field of the source charge. So that is the reason. Electric field is in one direction. This is the direction of the electric field, and this is the direction of your electrostatic force. So they are oppositely directed. So we will use this equation over here to find out what is dw. So over here this will be minus Q naught E into dx. Okay? Q Q naught E into dx. Q naught E into dx. And over here, this will be dw. You already know that E is 1 by 4 pi epsilon naught, so we'll write over here, this will be 1 minus 1 by 4 pi epsilon naught. Then we will have Q, we'll put over here Q, we have this Q naught, Q naught, okay, Q naught, Q naught, divided by x square into dx, okay, into dx. We'll mark this as equation number 2. Then, in order to find C, this is dw. This dw is only the small amount of work done in moving the charge from E up to B. Say, if you want to move the charge from A very close, suppose up to point C, what do you have to do? You have to integrate the equation. Over here, see, if I draw that, this is point A and this is point C. This is point B. The displacement is dx. Suppose if I divide this into small segments, okay, small segments, that means what you have to do, and between dE also, dw is the corresponding work. Then what do you have to do in order to find the total work? You have to sum over all these small elements. So that is why mathematically, if I want to find the total work, then in moving that test charge, I have to integrate the equation. So over here, in order to find the total work done in moving that test charge Q naught from infinity up to point C, okay, from infinity up to point C, then you have to integrate this equation too. So over here, I will write W. Work done in moving the charge Q naught from infinity. So from infinity, we have to write W infinity. Where? Up to point 1. Up to point C, then you write W infinity C. Then over here this will be integration from 1. Integration from infinity up to point C. Then when you look at point C, the distance is how much? What is the distance of point O up to point C? The distance will be what? This distance will be your R. That means the distance from O up to infinity, up to this point will be infinity. Integrating from infinity up to point C. Up to point C will be what? Will be your R. So from here, these are what? These are your limits of integration. Okay? These are your limits of integration up to point R. Then from here, this is your dw. Then over here only simple mathematics. Then we will try to solve, so that we will arrive at the final equation. Okay, so from here, so this will be integration, okay, integration from infinity up to R. Then that dw, okay, that dw is given by that expression, okay, minus 1 by 4 pi epsilon naught Q naught divided by 1, divided by x square into dx. When you look at these terms, okay, when you look at these terms inside the integral, this quantity 1 by 4 pi epsilon naught, this Q naught, all these are independent of 1. All these are independent of dx. So we will take outside the integral sign. Okay, we will take outside the integral sign. So what we are left? We are left over here is, suppose we take outside the integral sign, then we have that minus. Then I will take this. I will write Q naught, and over here we will write 1 divided by 4 pi epsilon naught. Then you have integration from infinity up to R. And over here you'll have only that expression of 1 divided by x square into dx. Okay, into dx. Then from here, that means when you look carefully, I can express this integral inside as the in power form. Okay, I can express that integral inside in power notation, okay, or power form. So over here, this will be integral from infinity up to r. Then I can write that as this expression as x to the power minus 2 dx. Okay? X to the power minus 2 dx. Then from here, we'll keep on simplifying this simple step. Then from here, integration of x to the power minus 2, x to the power minus 2 is x to the power minus 2 plus 1 divided by minus 2 plus 1. Okay, this is the formula. And then you have to put the limits of integration. The limits of integration goes from infinity up to r. Then from here, as you keep on solving, this will be minus q naught divided by 4 pi epsilon naught. Then over here you'll have x to the power minus 1, and over here denominator term also this will be minus 1. And then the integral goes from infinity up to r. Then as we keep on solving, we will arrive at a certain condition. This will be q naught divided by 4 pi epsilon naught. Then from here, we can take this negative sign outside. Okay, it is like 1 divided by minus 1, and over here you have this x to the power minus 1 with that limits of integration. Okay, with that limits of integration. From here it is very clear that this negative sign and this negative sign will get cancelled. So you are left only with solving this expression inside. So from here again, this will be equal to q naught, the negative sign and negative sign gets cancelled. Then over here you have 4 pi epsilon naught. Then over here we can express this. This is expressed in exponential form. This is expressed in exponential form. Again, we can express that in terms of rational number form. Okay, 1 divided by x. Okay, the lower limit is this and the upper limit is that. Then from there, as we keep on solving and solving, we will find we will reduce to a simplified expression. Okay? A simplified expression over here, upper limit. In place of x, you put by r, which is your upper limit. Then minus. In place of x, you put by 1, you put by infinity, which is your lower limit. So you put like that. Then, okay, then this 1 by infinity, anything with 1 divided by a large number is equal to 1. It is equal to 0. So this term will go. So finally, we will get an expression of q naught divided by 4 pi, okay, 4 pi epsilon naught into r. What is this? This is nothing but the work done in moving the charge from infinity up to point C. That's just the work done. Then what is your target over here? Our target is we want to find the electric potential. So you can write over here. Therefore, the corresponding electric potential due to that point charge is given by 1. Is given by V equal W infinity up to C divided by 1. What are you doing? We are bringing that test charge Q naught. Okay, that is your test charge Q naught located at infinity. Okay, so this is the point, and you bring this test charge up to 1, up to that point C. So from here, that means you put what is this W alpha C. That means we will put that expression. Okay, Q naught divided by 4 pi epsilon naught into R, and then divided by 1, divided by this Q naught. Q naught and Q naught will get cancelled. So what we will get? We'll get a final expression which is 1 by 4 pi epsilon naught, then Q divided by R square. This is the expression for the electric field, or for the electric potential due to a point charge. So which means that V is equal to 1 divided by 4 pi 4 pi epsilon naught q divided by r square, which clearly means that v is inversely proportional to r, linearly. Okay? It varies linearly as the change in distance. So from here, v is inversely proportional to r, and v 4-point charge is given by that expression. Okay? 1 by 4 pi epsilon naught q divided by r. E, electric field, varies as the square of the distance. Electric field varies as the square of the distance. Or potential varies as the linear of the distance. Why? The power is 1. So if you have difficulty, you can review again the discussion previously so that you will understand the concept. Thank you.